Hi ladies and gentlemen, this is Mr. Green and we're taking up another topic in this statistics lesson. We're going to look at a binomial experiment. Now, I know we looked at the bimodal up earlier in the course in this particular unit when we were talking about combinations, and that was a expanding out of the equations, right? But a binomial experiment is an experiment where you only have two possibilities. It is either going to succeed or it's not going to succeed. Now, they list several different requirements here. One of them is that it has a fixed number of trials. You have to know how many of them you're going to do. The trials are independent of each other. They can't be dependent upon each other. So you have to put the cards back if you're using a deck of cards, okay? The outcomes can be labeled success or failure, okay? And the outcomes are complementary events of each other. So let me give you an example. When a magician has you pick a card and then you put the card back into the deck, he has a 1 in 52 probability of pulling that card out of the deck again, right? So if he pulls a card out, it's either a success or it's a failure. If it's a success, everyone goes, wow, that was a 1 in 52 probability. Okay? If it was a failure, if he puts the card back, he still has a 1 in 52 probability of pulling the next card out as being the correct card. But that's what a binomial experiment is all about, is getting a success or a failure. Okay? So for exactly n trials, the probability of success is going to be the combination of n taken r at a time, the probability of r times 1 minus the probability of n minus r. This looks like a complicated formula. Let's see if we can't work through this one pretty easily with some marbles down here. Okay? So we have 6 red marbles, 4 blue marbles in the bag. So how many marbles do we got total? 10. Okay? So what is the probability of getting a red marble? Well, the probability of getting a red marble is 6 out of 10. What's the probability of getting a blue marble? The probability of a blue marble is 4 out of 10. They're independent of each other because we're going to keep putting them back each time. See, it says with replacement. Okay? And you're going to pick 8 different times to see exactly, or each time the color of the marble is recorded, find the probability of getting exactly 5 reds. 5 reds. Okay? So, we're looking for the probability of getting 5 red. Okay? So, in this situation, what are we looking at? We're looking at the combination of 10 things taken, how many at a time? 5. Why 5? Because that's what the R value is. That's the number of successes that we're looking to get. Combination of 10 things taken 5 at a time. And the probability of the red, the probability of R, well, that's going to be 6 out of 10. And this 1 minus the probability of minus R. Well, that's raised to a power, isn't it? So let's see here. The combination 10, 10, math, going over here to PRBX, 3, and we're taking them 5 at a time, and we hit enter, and we get 252. Okay? The probability of success is 6 out of 10, 10, and we're taking that to the 5th time, 5th power. And my probability of not success is 4 out of 10, and we're taking that to the 5th power. We're raising both those to the 5th power, but that's just a coincidence of 10 and 5, okay? So if we looked at 4 of getting four possible ones. This would have been to the fourth power. This would have been to the sixth power. Okay? So let's take zero point 0.6 raised to the fifth power and zero point 0.4 raised to the fifth power. Okay? Oops, that was 4. 0.4 raised to the fifth power. Cool. So we're going to have to multiply some things together here. So I'm going to move up here to get the 252 times, move up here to get that 7 there, and up here to get that one. And we multiply those all together, and what do we get? A syntax error. Oh, darn. 252 times 0.76 times that one. And I hit enter on it, and I get 0.20. So that's telling me that it's about a 20% probability, or 20% probability. And I'm just going to look at my answer that I have here on the next page, and they got 27, but that's pretty much the same thing. The difference here is they're using 8 instead of 10, because we're going to do it 8 times, and I didn't take that into consideration. See the 8 here? I had a 10 there. And 8 minus 5, that's 5, that would be a 3. But they get 27%. Same thing. I'm just using the wrong number there. I made a mistake. I used the wrong one. Okay? Hopefully you see how binomial probabilities are calculated here. This formula, really easy to use. It's all on the calculator, so it's easy for you to just punch it in and get the right values. Okay? Okay, well, I will see you next time. One more topic in this unit, and then we'll be down to the end.